Let's take a look at a fourth type of application for rational expressions. This one is called work rates. If you notice at the top, it says if a job can be accomplished in T units of time, so however long it takes, then the hourly rate of work is 1 over T. So for example, if it takes you 4 hours to mow the lawn, in 1 hour, you will have 1/4 of that job done. That's what this is based on. So let's look at the problem. It says Letitia and Kareem are working on a neighborhood cleanup. Kareem can clean up all the trash in the area in 7 hours, while Letitia can do the same job in 5 hours. How long will it take them if they work together? Similar to the distance, rate, and time problem, this one works using a chart. So you want to draw a chart on your notes. Probably going to have to extend this a little bit. The first column is labeled hourly rate, the hourly rate. The second column is the time it takes working together. And the last column is the fractional part of the job done. Now let me show you how this works. We have two people, Letitia and Kareem. Our problem tells us that Kareem can clean up all the trash in 7 hours. So it takes him to finish the job 7 hours, meaning in 1 hour, he has 1/7 of the job done. Letitia can do the same job in 5 hours, meaning in 1 hour, she has 1/5 of the job done. Now the question is, how long will it take them working together? So we're going to say let X equal the time needed working together. Well, that's going to be the same for each of them. Now, it may be counterintuitive to some of you, but you don't just add up 5 and 7 and divide by 2 and say it's going to take them 6 hours working together. It just doesn't work that way. She's contributing more in a shorter amount of time than is he. So we have to show what fraction each of them is contributing. And the way that you do that is you multiply these two together to get that one. So it's 1/5 times X, which is X over 5. His is 1/7 times X, which is X over 7. What makes this kind of problem perhaps easier than the distance, rate, and time problems is we know that the part of the job contributed by her plus the part of the job contributed by him, so X over 5 plus X over 7, is always going to be equal to one whole job. And that's the way the equation is set up. Now, all that's required is to get rid of the denominators the way we have done that with all of our equations of rational expressions. So my LCD here is 35. So I'm going to put each term, including that 1, in parentheses. We are going to multiply by 35. I get 7x plus 5x equals 35, or 12x equals 35. We divide by 12, and if it had been 36, it would have come evenly 3 times. So what we end up with, since it's 35, is something close to 3, but it's 2.91, and it keeps going. So if I round that off, what it's saying is together, working together, it only takes 2.9 hours. And that may be surprising to some of you, that it took much shorter than it did for either of them working alone. Now, if you want to know what that is in hours and minutes, and you should, I know that it's 2 hours. Now I need to talk about what is 0.9 hours. How many minutes is that? So that's 9/10. 9/10 of 60 minutes in 1 hour gives me 54 minutes. So another way to answer that question is it takes 2 hours and approximately 54 minutes, because remember, we rounded this off. So 2 hours and 54 minutes working together.